Good morning. Welcome, everybody who either watches live or watches this in the future. By the way, if you haven't subscribed to the channel, please do so. I would greatly appreciate it. Slowly but surely making my way to my first milestone of 1,000 subscribers. So, with that, I'm going to get right into it. I'm going to start playing some music here. And make sure the volume is set correctly. Excuse me. So in the last stream that I did, I got to day 12, part 2, and I think I got close. But the answer that I gave, which I need code up for, was too low. Okay. It should definitely be lower than the original one because we're getting a discount, but it was too low. And I thought I had all the cases figured out. But unfortunately, as I looked through it later, I realized that I had missed something, which is this thing about adding a new line. So if you had the case when you might have been making, because of how you found the region, you're going through the points or the plots, you may be creating two lines and then you find the part that connects it. And so you need to make a new line that's based off of those two existing lines. Excuse me. And then, connect them. The problem is I removed the lines that I find. You can see that here. I removed that. I never add the line that I'm making. So, that's a problem. Now, I didn't test if this actually fixes it or not because, like I said before in a previous stream, that I want to do all the work as I'm streaming. I don't want to do any of this stuff. I mean, I might think about stuff or look at stuff later, but I don't want to do any new code or anything like that. All right, so let's run our tests. I don't think they're going to break because the tests were running before. But the test sample that we have doesn't run into that condition. So let's now... Whoops. There we go. What do we get this time? 936. So we get a little bit higher. Not much, though. But that's the right answer. Yay! All right. Good way to start the stream. Day 12 is complete. All right. Progress being made. Slowly but surely. Let's go look at day 13. Next up, the lobby of a resort on a tropical island. The historians take a moment to admire the hexagonal floor tiles before spreading out. Fortunately, it looks like the resort has a new arcade. Maybe you can win some prizes from the claw machine. Those machines that come down, they pick up, and you get so many prizes that way. The claw machines here are a little unusual. Instead of a joystick or directional buttons to control the claw, these machines have two buttons labeled A and B. Worse, you just can't put in a token and play it. It costs 3 tokens to push the A button and 1 token to push the B button. With a little experimentation, you figure out that each machine's buttons are configured to move the claw a specific amount to the right along the x-axis and a specific amount forward along the y-axis each time that a button is pressed. Each machine contains one prize. To win the prize, the claw must be positioned exactly above the prize on both the x and y axes. You wonder, what is the smallest number of tokens you would have to spend to win as many prizes as possible? You assemble a list of every machine's button button behavior, and prize location, your puzzle input. For example, oh god, button A. This list describes the button configuration and prize location of 4 different claw machines. For now, consider just the first claw machine in the list. Pushing the machine's A button would move the claw 94 units along the x-axis and 34 units along the y-axis. Pushing the B would do 22 and 67. The prize is located here. This means that from the claw's initial position, it would need to move exactly 8,400 units along the x-axis and exactly 5,400 along the y-axis to be perfectly aligned with the prize in this machine. Okay. The cheapest way to win the prize is by pushing the A button 80 times and the B button 40 times. Okay. This will line up the claw along the x-axis and along the y-axis. Doing this would cost 80 tokens for the A presses and 41 for the B presses. For the saying, there is no combination of A and B presses that would ever win a prize. Pushing the A button 38 times and the B button 86 times. Doing this would cost and the tokens you had to spend is 480. You estimate that each button would need to be pressed no more than 100 times to win a prize. How else would someone be expected to play? So this is an optimization problem. Yippee! So I'm just curious. If we did something like this, does this work? I'm not sure if it does. Nah, that doesn't do it. I didn't think that was the way to solve it. I just had to try. Well, you could brute force this. Let's take a look at our puzzle input. Right, you could say Maybe the right way to think about this is this. Because it said no more. You don't need to do it 100 more times. So if A is 1, and we did all of the B's 0 to 100, this is simple math. A computer can crunch that pretty easy. Does A being 1 and B being 1 give you a solution? No. So what you could do is find, whoop, that's wrong. That's got to be 5400 here. All right, and then that's 34 and 67. I think the hardest thing is going to be to parse this crap. I think they're all pluses. Yeah, because you got to move forward. Let's make sure that we... So you parse it, you find... You find for each button what their X and Y's are. And then you just go through and you say for A is 1 to 100. B is 0 to 1 to 100. If the first set equals the target and the second set equals the target, then you figure out the cost. Now, this is a brute force way of doing it, but this should be pretty simple. Should. God, I cursed it already. It should be pretty simple to figure out what the what the minimum is. The actual fun thing is going to be parsing this. I could go the regex expression route. But I could say I know that line 0, mod 4 is A, then B, and then the prize, and then you have an empty line, and you have A, B, and prize, empty line. The tricky thing is at the end is you just you'd skip over. So we need to get a set. We need to get a set of machines. The machines have buttons. Buttons have X's and Y's, and then it has a prize. So we have a machine that has 2 buttons and a prize. The prize is located at X and Y, and the button has an increment and a Y increment. So what we want to do is get a list of machines. Just getting all the parsing fun out of the way. So that should skip over the last one, even if it goes beyond the, like, says we're not going to index into that array. Okay, so to get button A, actually, let's do this. And let's make it callable. So then it lights up. Okay. What we want to do here is we want to get so we want to move one ahead of where we found that. We trim it. Okay, so that gets us basically this. Except, no, let's so that gets us the X and the Y on each side. Just trim it. So we trim that. We get the plus. So we want to say +1. What is... Oh, sure, everything after. Okay. Cannot convert from int to system read-only. I don't get it. If I have trim it. Oh, yeah, of course I wouldn't. We want to get the there. Easy. For some version of easy. And then the Y is the first one. Or we find the index, we go 1. Ah. If we hit the 3, that's the indicator we need to make a machine. So here what we would do is we say machines.add a new machine giving A, B, and the prize. Yeah, we'll get there. And then we null these out. There. Now we do B, which is basically the same, which is fine. Because the logic is the same either way. And now the prize. The prize we want to split. So we want to say location. X location is everything after and equals. Okay, I think that now parses out. There. Okay. So let's create a test just to see if we're going to get the right. Parsing and stuff like that. We can't get the well, we can actually get this set up to say, here's what the answer should be. Of course, it's not going to give that, but that's okay. What I'm more curious about is, does it parse? What's the problem? The input string was not in the correct format. Huh. Well, this worked here. That worked just fine there. Why isn't it working here? Yeah, there it does it. I get it's the off by one thing, but I don't understand how we got the A and the B correctly. But it's not doing the right thing for the equals. I get it's because it's trimming. It's not the exact same location as where I guess what we could do is say a little verbose, but we'll make sure that we're trimming all this. There. 94, 34, 22, 67, 84, 5. Oh, we didn't grab the last one. Off by 1 issues this morning. Yay. Because we don't get to that last line, and so we want to make sure brute force it. Now we should have 4. Yep. Okay, so that gets us our machines. That's eventually what we want to... So we want to go through each machine. And we say for var a is equal to 0, a is less. Well, we want to do it from 1. And then we want to do 4. What we want to find is the cheapest. I'm assuming here that we're going to find one answer, at least one answer. There. Now it's just a matter of finding the answer. So here we say if machine dot a dot x increment times plus machine B button right? Times B equals X and the Y increment equals the reward of Y then we need a token. Actually, we don't need a list. We can just say it's and so we find that that is an answer with pushing A or B that much. And we say the cost is 80 times A plus 40 times B. If well, we don't find one. That's if we don't find one, then I guess we just don't add it. I actually like the array approach. So if we actually found a solution, let's find the cheapest one. Yay! I screwed up. Well, I must have found something. So... Okay, so we have the four machines. Wait a minute. Wait a minute. Wait a minute. What is A? 80. And B is 40. What? Oh, that does give the answer. Oh, it... I was doing it completely wrong. I was, not incrementing. Fastest wrong syllable or something. What do we get for this? Yay! Yay! And there is much rejoicing. All right, git commit part 1 of day 13 is complete. And you know what, folks? We are halfway there. Right? 25, halfway there. It's all downhill from here in probably more ways than one. I was looking at the, where's the statistics? Stats. So this is one that shows how many people, or how many completion statistics. So each plus, or yeah, so you can see that when you start out, you know, you get this kind of, oh, everybody's excited, and then it just starts to taper off a little bit, you know. So continue to part 2. How are you going to screw this up now? As you go to win the first prize, you discover that the claw is nowhere near where you expected it would be. Due to a unit conversion error in your measurements, the position of every prize is actually that big number higher on both the X and Y axis, adding blah to the X and Y position of every prize. Add that to the X and Y position of every prize. After making this change, the example above would now look like this. Now it is only possible to win a prize on the second and fourth claw machines. Unfortunately, it will take many more than 100 presses to do so. You suck. Doesn't tell me how he presses. So, yeah, this is where brute forcing it with the simple approach works just fine. But doing it for whatever this is, what was that, 1 billion? $10 trillion. That's a big machine. So this is faintly recalling something in my head about linear equations and optimization. Right? And we definitely have to switch to making sure everything is along. Yeah, the problem is that it gave you before, oh, sure, the most you would ever need is 100. I'm guessing it's saying some kind of something. I'm just curious. If I run this the way it is, I'm just curious, do I ever find one where we didn't get an exact solution? That doesn't mean when you start getting that many more, that big of a number, that suddenly more solutions would pop up. Yeah, it never hits it. Now, again, that doesn't hold true if you suddenly make it so that the rewards are multiplied by a trillion. Obviously, 100 is going to be nowhere near what you need to do. Even if you did like 1 of A and 100 of B, you're nowhere near close. But again, you're dealing with 10 trillion, so you can't... You can't even say, like, let's start at 1 billion, because that would require, you know, the magnitudes are so gargantuan. Sure, let's go look up some math. Yeah, this is all great. Let's math this morning. Let's not. I mean, this is... I can't even tell if this is what I want. And the simplex method. Here I am trying to learn simplex methods in a live stream. This may be something I need to read off camera, because I'm not going to subject people to watching me learn about the simplex method and matrices and what we want to do is minimize the function this, right? Because we want to get the minimum. See, what I don't get is the whole thing of this, where you do this less than or equals to. Okay, I get this is mathy math, and this is all a bunch of math, and math is good, and yay math. I truly mean that. I'm like reading this going blurf. I at least remembered something about optimization of linear equations. I just don't remember what you do with it. But this feels very well, we don't want to maximize a function, we want to minimize it. Yeah, the problem is asking you to minimize it. This can be accomplished by instead maximizing it. If anybody's watching this, tell me if I'm on the right path. I mean, this does, if this can be applied to the problem at hand, if the constraint equation is given as an identity, it can be replaced by two inequalities having this identity as an intersection. So we compare these up. I'm thinking this is the right path, but I'm not sure. Because if I can do this using the simplex method and maximizing the negative and then inversing it, and if that just with a couple of little graphy graph things here, you know, sure, just bomb it into a thing and stuff. But this seems like instead of trying to do billions of calculations, This would give us the answer pretty quickly. So I think I'm going to stop here because, one, I do have to run some errands this morning, and two, there's no way I'm going to want to go through this while I'm doing a stream. That would be torture. So I think what I'll do is I'll see if I can apply this, especially with some of the things they talk about down here, because, we're trying to minimize, so we want to maximize. And we're also given identity constraints. We're not given inequality constraints. Where we could just take this and say, well, it's got to be less than this, and then it has to be the negative of everything. So I'm going to do that. I'm going to read up on this more and see if that's the way to tackle this beast. And maybe that will give me the right answer. I'm kind of curious. For 13. Well, a lot of people completed both. Each star. So 45,000 people got it. So it can't be that hard. I mean, 250,000 people got. I get nervous when I see like 21. Oh my God. I was like, that's like the lowest of accomplishments. Well, I think this is saying that like the majority of people finish both. And this one was actually so simple to do the second one that a lot of people just, if you get the first part, you easily can do the second one. That's what I'm reading that as being. Maybe. I don't know. But I've got the feeling that this is the way to go. I just have to actually figure out the math to make it happen. So, just in case the world implodes on itself. We'll give that a try. I mean, the thing that's funny is that if you read the about, you don't need a computer science background to participate, just a little programming knowledge and some problem-solving skills. Nor do you need a fancy computer. Every problem has a solution to complete. Yeah, I mean, if you do the linear optimization, if I'm looking at that document correctly, if you set it up right, getting the answer is actually really quick. So, yeah. Most 15 seconds on 10-year hardware. So, problem-solving skills, though. None of the puzzles say things like build a red black tree are given this big O notation. I get what this person is saying, breaking it into smaller problems. And I'm not saying that applies directly to this. But I look at something like this and I go, well, you have, again, I don't see how you can do this brute force. You just have too many possibilities. And of course, you could get rid of a whole bunch of them, because a lot of these, starting at 1 and 1, there's just no way you'd ever be able to get there. You know, you'd have to have at least these many to do it. So like if you look at, like if you did 22 and you did 100, you would never be just button Bing to get that. There's no way. This could, but then what's the, that's where you start. Yeah. So I don't see how you can do this without knowing, hey, there's a way to optimize the problem. But I could be wrong. I could definitely be wrong. So I'm going to think about this some more. Maybe I'll do a stream this afternoon or this evening, and I definitely need to do some research on this, because I'm not sure if I'm going down the right path or not. So with that said, I'm going to stop for now. Maybe do some streaming later. If you are watching or you're watching in the future, thank you for doing that. Please subscribe to the channel. I would greatly appreciate that. If you know I'm wrong, tell me. But otherwise, I will think about this, mull it over, and come back with hopefully an approach that will hopefully work. So thank you all for watching. Take care, and I hope to see you in the future.